everyone, welcome to my channel. In the past video we saw about the TRUSS module of the ISS. Today we are about to see the next module made for supporting the structure of the ISS, the S0 starboard truss. Let's start the video. The S0 starboard truss on the International Space Station is like a central support beam of a building. Just as the central beam provides stability and support to a building, the S0 truss is crucial for the structure of the space station. It is located at the center and helps connect other parts of the station, ensuring that everything stays in place and functions properly. This truss supports essential systems like power and cooling, much like how a central beam supports floors and walls in a building, making it a key component in keeping the space station strong and stable. The S0 truss plays a pivotal role in the functionality and operations of the International Space Station ISS. Its primary purpose revolves around power distribution and thermal management, essential for sustaining life and conducting scientific experiments in the harsh environment of space. As part of the station's backbone, the S0 truss serves as a central hub for routing power from the solar arrays to the pressurized modules of the ISS. It acts as a critical link, ensuring that electricity generated by the solar panels is effectively delivered to various systems and equipments within the International Space Station ISS, including life support systems, communication devices, scientific instruments, and control systems. Moreover, the S0 truss facilitates heat dissipation from the pressurized module to the external thermal radiators located on the truss segments, such as the S1 and P1. This thermal regulation is crucial for managing internal temperatures, preventing equipment from overheating, and maintaining a habitable environment for astronauts. The intricate network of thermal loops and radiators interconnected through the truss system helps in efficiently transferring excess heat away from the station's vital components into space. This compatibility is essential for ensuring the proper functioning and longevity of the ISS systems. The development of the truss structure for the International Space Station ISS has undergone significant evolution from the initial Space Station Freedom design to its current form. Originally made as part of the Space Station Freedom, the truss structure was envisioned to support various functions, including providing attachment points for scientific instruments, solar arrays, and thermal radiators. However, the ISS program evolved with international collaboration and changing mission requirements. The truss design and configuration were adapted and expanded to accommodate new modules, experiment, and capabilities. Manufacturing the truss components for the ISS involved a collaborative effort among multiple entities. Fabrication processes such as investment casting, steel hot rolling, friction stir welding, and TIG welding were utilized to create the intricate components that make up the truss structure. Companies like Boeing, with facilities in Huntington Beach, California, and Michaud Assembly Facility in New Orleans, Louisiana, played key roles in manufacturing these components. Additionally, Marshall Space Flight Center in Huntsville, Alabama, and other facilities contributed to the production and assembly of these truss segments. The S0 truss, launched as part of the ISS Assembly Mission 8A, this mission, designated STS-110, took place on April 8, 2002 from Launch Complex 39B, LC-39B at Kennedy Space Center in Florida, USA. Space Shuttle Atlantis, on its 25th flight, STS-110 was utilized as a launch vehicle for this assembly mission. Atlantis played a crucial role in the assembly and construction of the ISS, ferrying various modules, truss segments, and equipment to space for assembly in orbit. During the ISS Assembly Mission 8A, which was part of the STS-110 mission, several crucial docking stages and maneuvers were executed to facilitate the installation of the S0 truss on the International Space Station ISS. The alignment and orbital adjustments were critical in preparing for the approach and docking procedures. Before the docking, the Space Shuttle Atlantis carrying the S0 truss had to align its trajectory and orbital parameters with that of the ISS. This involved precise calculations and adjustments to ensure a safe and accurate approach for docking. On April 20, 2002, at approximately 16:05 UTC, the docking process commenced, with Atlantis using its docking port docked with the PMA-2 pressurized mating adapter 2 located at the Destiny's forward position on the ISS. This docking interface allowed for a secure connection between the shuttle and the station, enabling the transfer of astronauts, equipment, and payload between the two spacecraft. The docking was a crucial step in the assembly mission, as it established the physical connection required for subsequent spacewalks and installation operations. Following the successful docking and process of retrieving the S0 truss from the shuttle's cargo bay and its subsequent attachment and installation onto the ISS began. Astronauts conducted multiple spacewalks as part of EVA's extravehicular activities during STS-110 to install the S0 truss. These EVAs involved precise maneuvers using the Canadarm2 robotic arm to handle and position the truss segment for the attachment. On April 11, 2002, during EVA-1, astronauts Stephen Smith and Rex Wilhelm installed the S0 truss on the Destiny Laboratory module, marking a significant milestone in the assembly of the ISS. Subsequent EVAs during the mission focused on continuing the S0 truss installation, reconfiguring Canadarm2 for truss operations, and preparing for future EVA hardware installations. The S0 truss was attached on top of the Destiny Laboratory module using 4 module-to-truss structure MTS struts during STS-110 in April 2002. This attachment ensured a secure connection between the truss and the lab module, forming a vital part of the International Space Station ISS. The entire process from alignment and orbital adjustments to docking with the PMA-2 and subsequent EVAs for S0 truss installation demonstrated the precision, coordination, and expertise required for assembling complex structures in space as part of the ongoing construction and development of the International Space Station.
I'm just what I am. That's all.
The S0 truss segment of the International Space Station ISS is a critical structural element that supports various systems and scientific instruments, essential for the station's operations and research endeavors. Now let's see the parts of the S0 truss segment. DC to DC power conversion unit. The DC to DC converter plays a critical role in the functionality of the S0 truss segment. Its primary purpose is to convert direct current DC electrical power from the space station solar arrays into a form usable by the station systems and equipment. The converter unit is located within the S0 truss segment, strategically positioned to efficiently manage and distribute power throughout the International Space Station ISS. This ensures that the electrical power generated by the solar arrays is converted to appropriate voltages and current levels required by various onboard systems and experiments. Connection mechanism. Umbilicals, umbilical mechanism assemblies, struts. The connection mechanism of the S0 truss segment comprises umbilicals, umbilical mechanisms and struts. These components are essential for linking the S0 truss to the Destiny Laboratory module and facilitating the transfer of power, data and other resources between the connected modules. Umbilicals are essentially cables that carry electrical power, communication signals and fluid lines, such as for cooling systems, between different parts of the space station. The umbilical mechanism assemblies ensures proper alignment and secure connections between the truss segment and Destiny module. Struts provide structural support and stability, ensuring that the connected modules maintain their desired position and orientation relative to each other. Charged Particle Directional Spectrometer. The Charged Particle Directional Spectrometer (CPDS) is an instrument located at the top of the S0 TRUSS segment. Its function is to detect and analyze charged particles in space, including cosmic rays and solar energetic particles. By measuring the energy, direction, and composition of these particles, the CPDS contributes scientific research on space weather, radiation hazards to astronauts, and interaction of cosmic particles with Earth's magnetosphere. The CPDS helps scientists and engineers better understand the space environment and develop measures to protect spacecraft and crew members from potential radiation risks. Multiplexer and demultiplexer. The multiplexer and demultiplexer MUX/DEMUX units located at the center of the S0 TRUSS segment are vital components for data communication within the space station. The MUX is responsible for combining multiple data streams into a single high bandwidth signal for transmission, optimizing the use of communication channels. On the other hand, the DEMUX performs the reverse process, separating the combined signals back into individual data streams at the receiving end. These units are crucial for managing data flow efficiently between different modules, payloads, and ground stations, supporting the exchange of scientific data, telemetry commands, and other information essential for ISS operations and scientific research endeavors. These components collectively contribute to the functionality, connectivity, power management, data handling, and scientific capabilities of the S0 TRUSS segment, making it an integral part of the International Space Station ISS infrastructure and operational success in the space exploration and scientific discovery. The S0 TRUSS has a length of 13.4 meters, 44 feet, and a diameter of 4.6 meters, 15 feet, and a mass of 13,970 kilograms, 30,800 pounds. In conclusion, the S0 TRUSS is vital to the ISS as it supports important systems and ensures stability. Its role underscores the advanced technology that keeps the ISS operational and emphasizes the importance of global cooperation in space exploration. I hope this video on the S0 TRUSS was interesting and informative. I'll meet you in the next video with another interesting ISS module. Take care. Bye.